Okay, so off we go to our third page. Let's see how we do. So page three starts with a couple of problems where I'm asking us to take a given graph and come up with a formula. So this is a limison. You can quickly see the y-axis symmetry, so it has to be a sine. I also very quickly noticed that there's no loop here, which means when I look at these two numbers, this value, the A and the B, as we keep saying, the A is going to be larger than the B. I also noticed that when I looked at the kind of the off axis, I'm trying to look at the y axis, but as it turns out, if I look right here, that's a 5. That tells me that A is going to be 5, but they have a sum of 8, so it needs to be a 3. And that's going to make sense because 5 plus 3 is 8, but 5 minus 3 is 2, and we're done. Similarly over here, I know that it's a sine because of the y-axis symmetry. I also know that it's a rose, so it's going to have some number of petals, and I notice that it's an odd number of petals, so I don't need to worry about the doubling thing. So I see that I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 petals, so it's going to be every 9 theta, and the length of those petals is 9, and so that should be it. Now, the only thing that could go wrong, which is kind of weird, is it might be a -9 because all that would do is flip the thing over, and I don't know if it's upside down or not. But what you might want to do to double check that is just graph this in your calculator and see if it's in fact what we wanted it to be. So, if we came in here and changed this to 9 sine 9 theta, we could double check and make sure that it in fact looks roughly like what we thought, because you'll notice there's a pedal up. And so that looks like I did okay. Now, for number 19, it specifically says a cardioid, and it has y-axis symmetry. So it's going to be r equals some a plus maybe a minus a sine theta, but it has to be a sine, and they have to be the same. But it says it hits the x-axis at 6, so I know it's going to have a couple of 6s. Because again, if it has y-axis symmetry where it hits the wrong axis, is going to be that way. But what I can see is 6 and 6 makes 12, but it's saying that that maximum value is down here at 3 pi over 2. And if it's a cardioid, then that means it's going to have to be a downward cardioid to hit that value. Now, almost done, but when we get to number 20, it says we've got this loop, it's a diameter, there's all sorts of things that are happening. But specifically, you'll notice that I keep referencing pi over 3s. Well, when you do trig, every time you take a trig ratio, you will get irrational numbers for almost everything except for very specified values. And this is not an irrational number. So the only way that you can ever take a trig ratio of a pi over 3 and get a rational number is if it's a cosine. So it has to be the cosine of pi over 3 giving us that half. Now, the second thing that I know is that somehow I have these a plus b's, and they have to be a total of 19. And the a, taking away that b value, whatever that happens to be, has to be 5. So I have to come up with two numbers that are 5 units apart that sum up to that. So if you think through numbers that add up to 19, 1 and 18, 2 and 17, 3 and 14, 5 and oops, I messed that up. I missed 4, right? 4 and 13, 5 and 12, 6 and 11. You just keep going down the line. I have to come up with some numbers that are exactly 5 units apart that have a sum of 19. And I have evidently really messed that up. That'd be 5 and 14. I really screwed that up royal up in here. But the reality is 7 and 12 do that, because 7 plus 12 is 19 and 7 minus 12 would be 5. But I just have to be careful that I make the second number the 12 and the first number the 7 in order to do that. Secondarily, what I noticed is pi over 3 is here, and it's 13 units out this way, but it's 13 units out here at 5 pi over 3, but only 1 unit going to the left. So the thing is quite clearly extended to the right, so that's going to be a plus. All right. Now, symmetry is a little bit tricky, and so I'm just going to go, and I actually purposely gave us the easy ones, but one of the tests for y-axis symmetry is to replace r theta with a negative r and a negative theta. Now, that seems weird, but if I rotate backwards, so if I have some value here, r theta, if I rotate backwards, negative theta, but then go backwards, I'm going to land up here. So this value is negative r negative theta. And that is a perfect look of a y-axis symmetry. So if I replace r with negative r, and I replace theta with negative theta, what I noticed is sine is an odd function, which allows that negative to pop in front. And I could just multiply both sides by -1. And that very quickly got me back to where I started with, which demonstrates that this function actually has y-axis symmetry. And so I'm done. Whereas this one over here has x-axis symmetry, and the easiest test for x-axis symmetry is to replace r with r and theta with negative theta. So keep in mind, if r theta is here, r with negative theta would be down here. And so again, r is 3 plus 9 cosine of negative theta. But because the cosine is an even function, we can just throw that negative away and just go like that, and bam, we've got it. So that is a quick way to demonstrate that they both have x and y-axis symmetry. All right, and that'll do. Now, some of the ones are harder, but you look back at your notes, they're in there. I just didn't want to do the hardest ones on the review. All right, I'll see you back in class. Bye-bye.